Afternoon, and thank you for joining us today. We would like to welcome you to our ServiceNow Public Sector Tech Talk, Future Ready Federal IT, Unlock AI-Driven Operations with Secure Automation. At this time, I'd like to hand the floor over to our speakers. Chris, the floor is all yours.
Thank you, Kaylee, and welcome everybody. Hello, everybody. My name's Chris. I'll be leading today's session alongside my friend Mark here. We're here to talk about something that's top of mind for many federal IT leaders, and that's how to modernize operations while staying ahead of growing demands around security, compliance, and mission assurance. And we all know federal agencies are under enormous pressure right now. You need to ensure mission assurance, have high compliance with mission assurance and comply with data and operational resiliency. And at the same time, you need to enable staff to do more with less. We know that's a very tall order. And so today we're going to show you a way to become more proactive and preventative in your day-to-day IT operations. So that's why we're focusing on service operations and a new concept called autonomous IT. It's no longer just a buzzword, it's a future vision. And it's becoming essential right now. So for federal agencies, autonomous IT is going to help you shift away from reactive firefighting and towards proactive AI-driven operations that strengthen resilience and reduce risk. Our goal is to help you achieve a 3-0 outcome where you minimize outages and incidents, all while keeping a cloud-native approach. By the end of this session, you'll see how two ServiceNow innovations, the Learning Enhanced Automation Playbook, or what we call LEAP, and Health Log Analytics, or HLA, they can help federal agencies and organizations build immediate momentum today while laying the foundation for future AI-driven operations. So let's talk what that journey is going to look like. Today, many agencies find themselves stuck in a reactive mode, chasing a flood of recurring incidents, responding to compliance audits, and dealing with urgent fires as they come up. This leaves very little time or space to get ahead, but the path forward is clear. It's made up of two critical solutions for the modern agency. Like I said earlier, LEAP and HLA. LEAP uses your existing incident history to glean automation opportunities from the data you already have in-house. We use ML clustering to group incidents and then Gen AI to create a knowledge-based articles and automations that significantly reduce resolution times. On the HLA side, HLA collects and correlates machine-generated log data in real time, and it uses that data to help operate proactively before an outage happens, and then provides instant data-driven advice to resolve issues. So as you can see, together, HLA and LEAP can help move agencies from a reactionary mode to helping solve problems, to anticipate and prevent and automate them out. And really, that's the foundation of autonomous IT. And with that big picture in mind, I'm going to hand it over to Mark. But first, we want to pause for a polling question. So looking at this slide, where do you feel your organization is along the maturity curve?
Yeah, I see a lot of reactive responses, which just means that there's a lot of room for improvement here, which is good. And when we're talking about going from reactive towards that ultimate holy grail of self-healing, I think it's important to understand the challenges that automation teams within agencies may be having already, and it's some that are very common, which is, how do I know I'm making the most impact possible on what I'm supposed to be automating? Where are my greatest opportunities? How do I even measure potential impact? What should I be focusing on, right? Where do I even start from? What's good to understand about the platform is that you already have the data in there. You have those ITSM tickets that have been processed over time. So there's a nice body of knowledge there, and we can implement machine learning and AI on that data you already have on platform to start to glean out those good starting points for where to implement automation, right? Where to implement playbooks. So that's going to achieve that entire process from just gleaning the data and finding out where to start to actually getting a set of steps that are something you can automate to then ultimately putting that automation in place. That's going to involve process mining, robotic process automation type activities, business process management, right? And so Leap was designed to really get you kickstarted and provide three clear pillars of value. And that's with actually being able to discover those automation opportunities, generate AI-driven resolution steps. So that's where Gen AI comes into place, with the discover piece being more our traditional machine learning. So it's not that machine learning just started in the last 2 or 3 years. It's an older technology than that. There's traditional ML methods to discover where to start. We generate the resolution steps with AI, with Gen AI, and then ultimately create a playbook also utilizing that generative AI capability. So taking the step-by-step words and text, which could be maybe a KB article, and actually turning it into something that can be automated, right? And then how do you measure that? So you've implemented this automation. How are we going to make sure that it's actually being utilized? It's actually providing me with those mean time to resolve resolution decreased times decreased, and faster root cause, and more ticket deflection, right? So here's the high level process of what Leap achieves. So it takes the entire body of incident tickets within your environment and clusters it together based on similarities and descriptions, resolution notes, and any kind of case notes throughout those tickets, and makes clusters out of them, essentially groups of similar incidents. From those groups of similar incidents, we can measure how long those incidents take to resolve. So we know we can then estimate what are the MTTR, mean time to resolve benefits? What are the potential monetization benefits that can happen here? And what should be prioritized for automation based on how many tickets are in the cluster, again, how important or the priority level of those tickets in that cluster, etc. So that's all about those automation opportunities. What should you be automating? And then we can implement Gen AI to run over each individual cluster here to then better understand what's the common thread within each of these tickets. How are they usually solved? What are the most common steps you can take to fast track resolution of that? And so from utilizing Now Assist and Gen AI, we'll get resolution steps for these clusters. And ultimately from there, we can create problem tickets that have the resolution steps built in. So now any new ticket that comes in with a similar title or a similar set of criteria will be associated with this set of resolution steps. And after some time, we can actually take those resolution steps, click on our ability to generate a Leap, a learning enhanced automation playbook, and we can actually create flow designer flows within those playbooks that give us that wireframe to really begin automation. So instead of having to start completely from scratch, do your own data mining, we're getting you all the way to having the bits and pieces of that flow in place, so that we can essentially become self-healing. We can go from reactive to self-healing in record time, right? And at the end of all of that is when you have those automations in place, we can start measuring things. How many of these tickets have been resolved? And how is this progressing throughout your environment? So I'd like to actually quickly show you what this really looks like. And for that, let me just make sure I can get this back up. Let me show you what these clusters would look like inside of an environment. So we'll go to the AIOps Leap workspace. And what you can see here is just the breadth and depth of the tickets that we've analyzed. In this small demo case, you see 82, but there are instances where we can analyze 300,000 or more incidents to really give you a large body of where are your automation opportunities, from whether they're critical, high priority, moderate, low priority, etc., and the potential savings. So let's go back to this more manageable demo use case here, where we can see we have four main clusters, and they've actually been prioritized based on what is high priority, moderate, and low. And again, those numbers are derived from the volume of tickets, what we estimate the money savings to be, what we estimate the time savings to be, and what is the frequency of monthly occurrence, right? So all these factors come together to form the priority of what a cluster may actually what clusters should be performed first, for example, or operated on first. And you can actually see the status of your different clusters in terms of, has this just been clustered together and you haven't taken any steps in terms of generative AI yet, or one that's maybe ready to now create a full playbook because we've at least implemented the most common steps that are repeatable. So we can click into these different clusters. And we can see here that I have already created on the generate resolution steps option. And we have 7 concrete resolution steps that seem to be the most common across these tickets, right? And from here, we can actually go ahead and then click this button to create a workflow out of these tickets. Apologies for that during the live demo. But again, if we go back, we can actually click through and see, well, maybe there's a moderate priority. I see I have an issue here with mid servers. If I click into the mid server, we have, again, a concrete set of 7 steps where it says check mid server connectivity between mid server and agents, verify agent configuration enablement to connect the mid servers. And all of these can then be filled in with any potential scripting, or decision steps within that particular playbook. And all these playbooks are essentially from our flow designer. Now, once you have some of these playbooks implemented, we can actually look at them and see, okay, I've deployed certain automations before. Let me take a look at how are they potentially performing. And so this is where you would see the number of tickets that have been resolved in the past, the amount of time that's been saved, as well as money. And we can actually view the particular playbook, and this is where we go to workflow designer. So here you could see how we've actually taken that set of words, those sets of steps, and using GenAI, we've actually broken it down into its individual pieces. And within these individual pieces, you can actually see that we have further steps that we can take and further pieces of automation. And so instead of having to just start with what even is the cluster that's most important to work on, what are the potential common resolution steps, and how would I even put them together in a flow? Leap has done all of that up front. So now you can put the finishing touches, maybe something that's specific to your agency or how you access Apache in this particular case, right? Those pieces can still be added in, but you are much further along in the path and you have a way of measuring this. And furthermore, a way of showing this back to stakeholders in terms of how many playbooks have been executed? What is the value that your work is actually bringing to the agency? How many tickets have been resolved by this, right? Over the last month, what are the incidents that have been resolved? What are the status of the various clusters that you currently have, right? So how many opportunities do you still yet have to work on? How many have actually a published automation, and how many just have the steps so far? Maybe we can turn those into KB articles. But this is essentially a holistic solution to really get you started with automations and then measure the value that those automations are bringing to you with the help of generative AI and Now Assist. One of the other ways that we can think about working with these clusters is actually understanding maybe there's other places within the platform where we can now gain value from if we look at some of these repetitive clusters. So if we're seeing that we have a lot of high CPU alerts or CPU utilization, maybe mid servers are being mentioned. If we start seeing that there's logs being utilized in here, this could be a good springboard towards utilizing health log analytics to become more proactive, reduce the mean time to resolve issues, potentially catch issues before they're actually happening. So even though Leap is targeted towards getting you closer to automation and closer to self-healing, it could also be a way to become more proactive with your machine-generated alerting. So I'm going to transition now into health log analytics and tell you a little bit more about that. Let's make sure I can get here. All right. So as I was mentioning several times through that Leap demo, our crawl phase is just to make sure that we can get that clustering together. So you can start to understand what's in your data, what's inside of your incidents, and where can you take action first. We can then generate resolution steps. and problem records so that those clusters are now associated with the most common steps for resolution to make it easier for level 0 type operators, level 1 type operators to take action faster, go through some of the most common troubleshooting steps. And then ultimately on the fly, we can create the automations that will be executed and then measure how those executions and automations are helping you resolve issues faster, how much they're actually saving you in terms of tickets resolved and time spent. So now let's talk about health log analytics and being able to utilize logs as an early indicator within what we call ITOM's predictive AI ops. It's really about going from a reactive state to, again, a proactive state to help you with self-healing. And so when we think about our agencies and our entire enterprises, there's a lot of scattered data. And that includes not only log data, but your traditional event sources, open telemetry, traces as well, right? And so all that scattered data can come into our predictive AIOps module along with your high volume logs, which can be correlated together, not only based on CMDB topology, which is a factor for correlation, but especially when we're talking about health log analytics, we can correlate just by metadata within the logs themselves. So you're not strictly dependent on a clean or mostly complete CMDB. You can actually start utilizing health log analytics, getting some proactive insights just by having the definition of an application service, or what we now call service instance, within the environment. I think that's very important to understand, that you can use these more advanced tools and more proactive tools from the get-go. Even if you're going through a cleanup of the CMDB, let's say, or a back to standard or some type of initiative like that, we can still have this potential correlation between sources just by extracting metadata from the logs themselves and putting all of these sources, whether they are traditional event-based and static threshold-based, as well as log-based into one area, which we call the service operations workspace, all to improve collaboration, attach those KB articles and knowledge base articles that may already be within your environment, and again, collaborate with maybe some automations that Leap has already discovered or any automations you've already created within your environment. It's a great springboard for correlating all that scattered data together so that we can enact some of these actions, all in the effort of, once again, improving your service availability, reducing mean time to resolution, ultimately improving the satisfaction of your operators and customers. So how does health log analytics achieve that high volume processing? So in what we would consider the legacy world, what you would have is a static threshold alert that may or may not be just a symptom of the issue, where essentially you're going CPU is above 90% or RAM is below 10%. And you end up having to find out what CI is impacted. Where should I be going? Let's go onto that machine. Let's figure out what's really happening. You're probably going to go to the logs themselves. Well, what logs are important? And then open that particular log file. Then say, well, when did this alert come through? And look above and below to understand and read through the logs manually to understand what may be happening here. Maybe there's something I can resolve because of what the application is explicitly telling me. And what you can see from that type of troubleshooting, it's reactive. So you're already in a fire drill while you're manually reading through these logs. It's labor intensive because you have to SSH onto that machine. You have to find the right log. You have to find the right timestamps. And it just takes a long time. So what we're doing is we're now ingesting those raw logs in high volume. We're talking tens of thousands of logs per second in many cases. And we're ingesting them via the ServiceNow platform and processing them with machine learning to quickly understand, well, here's the time frame, here's the CI impacted, and here's the specific set of text-based logs that are telling me what is going wrong. And now I can also correlate that with my traditional monitoring tools in the service operations workspace, with my changes, etc. And so the goal is to really be proactive because we're listening in on the chatter that the applications are actually telling us. From an infrastructure perspective, how do we achieve that high volume? We do it by having a separate stack. This is all transparent to you, but essentially we want to be as flexible as possible with ingesting data. So we can take it from any data lake, even your uh, directly from your individual servers with our agents, or agentless with open telemetry and things of that nature, and ingest them into our separate stack where we have the ability to process millions of logs in a minute. And so our goal is to take all that processing and distill it down into the few set of alerts that would really help you resolve the issue. So let's kind of walk through a scenario that's very common, where we have the traditional world where something maybe happened with an Oracle DB. Maybe the order system is now unavailable. And after a few minutes of getting enough indicators, maybe explicit logs we know to look for, saying that the process is blocked. All right, we have an incident generated from a set of events, but now there's a fire drill, right? We're kind of behind the eight ball here, and we're working to resolve a full outage. But if we're able to implement all those early detection sources that are scattered throughout the agency, we could actually get out in front of this issue, because we may have been seeing the order system having slow responses many hours earlier, which actually progressed to be much worse an hour later. And therefore, we also got authentication failures and a very specific log line telling us that there's problems from log analytics without knowing explicitly what type of authentications or failures in general to look for. And all of that can be correlated together because they're sharing the same CIs. Maybe they're sharing a very similar time frame. They're sharing the same service instance. So our system would correlate all that together into a cohesive group of alerts, which can be analyzed by generative AI. Obviously, known knowledge-based articles would correlate with that. We would know which admin groups or which support groups to assign that group of alerts to. And essentially, any known automations can be taken, or action can be taken hours in advance of the actual full order system being unavailable. So we're catching the issue on the ramp up as it's increasing, giving your teams that time to be proactive, preventative, and maintain system uptime, instead of being on the back foot and having to go through that fire drill. So let me show you what this also looks like within the platform. So let's go here. And so where I am right now is in the service operations workspace. Uh, Within the service operations workspace, we have the express list, which shows you a chronological order of all the alerts within our system. And you can actually see here our ability to correlate between many different sources. So we're correlating between Dynatrace, VMware, our own agents, Zabbix infrastructure monitoring, but also our ability to use AI and log analytics to provide you with some even earlier indicators than the ones above, which are a little bit more symptomatic, as I was mentioning before, right? 15% free space, or latency being increasing quite a bit, right? But what we're seeing here down below is from log analytics. Let's click into this group. And what we can actually see here is our ability to detect not only explicit messages, which are showing an execution RabbitMQ messenger listener failing, but we can also see that there's a great increase in general of logs coming from the Oracle DB. And we can actually see that there's a particular HTTP status of 408 that's above normal. And there's actually a very specific meaning to this. So why are we just saying above normal? Well, because you haven't set any static thresholds around this. You didn't tell HLA to explicitly look for 408s. It just saw that within the logs, you have HTTP status codes, and it's measuring them individually. And so usually we never see these 408s happening, or they're very inactive, near zero. And all of a sudden you see this step up. So we're giving you a display, a visual understanding of why do we believe the machine learning thinks this is an anomaly. It's out of the ordinary. And then furthermore, here's all the metadata that's coming in with these logs as well. So you're getting a rich set of data to really try to pinpoint and help you understand what is the impact to the business in advance of other tools. So you're getting these 408s, and the 408s are really coming from the ordering API, right? The order API. There's status and offers, but orders are failing. So you can be fairly sure this is a very important alert to look at. And again, coming in several minutes before other tools, even talking about extended latency, etc. And we know that there's listeners failing, so this is definitely impacting our system. But if we go to the most recent alert within Oracle DB, we're able to see that this progression of this graph looks very similar to the progression we saw with the 408s. So we've correlated all these alerts together because their anomaly shapes are the same. They share the same metadata, and they also share the same service. You can even see the comparison of what the same hour 1 day earlier looked like to today, because again, there is no static threshold. You didn't tell us explicitly what to look for. We're finding the anomaly, finding the needle in the haystack here. And so there's a great increase in these Oracle 130 logs. But if we look into the impact, we see the impacted CIs as well as the other impacted services or dynamic CI groups like Linux servers and Windows servers in this case. If we expand the cause, we actually see 90% of these logs are trace level logs, which shouldn't be normal in normal operating conditions. Furthermore, through the power of the platform, we're integrating here with an ITSM piece called change. And so we see that there is a recent change associated with this particular alert. So if we click into the recent change, what we should be able to find here is the person responsible for that change. And we'll be able to contact that person and really understand what has happened here, because it seems like I see this is a DevOps execution step. And essentially what's happening here, if we look into the details, is that what was actually happening is that someone changed debug level to trace level. And so we can now be pretty sure that this change has caused this issue, and we can contact this person for resolution, right? Or roll back the change. So this is really giving us that proactive ability to rectify our mistakes before there's a full impact to the system. And we can now make sure that the application is operating in steady state conditions without having to actually be in the fire drill of it actually going down and impacting our systems. So with that being said, this is how HLA and predictive AI ops can help you be proactive. And then we also saw how AI ops leap can help us be preventative and get to that self-healing state, right? And the two can ultimately work together by helping us connect the clusters that we are seeing with potential log streaming opportunities, as well as full automation and self-healing opportunities. So with all that said, Chris, I may have gone a little bit quickly, but I'd like to pass the ball back to you.
That's okay. Thanks, Mark.
See if you could wrap us
I
up.
appreciate it, Mark. Thank you very much. It's a great walkthrough. And what I want to highlight here is how practical this really is. By simply leveraging the incident history that your agency already has, the LEAP, the learning enhanced automation playbook, makes it possible to unlock quick value, things like faster mean time to resolution, better prioritization, and as you saw, AI-guided remediation. So in other words, it doesn't require massive transformation to start seeing results. So let's pause for a quick poll and let's gauge some interest about proactive detection. Can you see this fitting into your agency to automate out manual tasks? So let's give about 30 seconds or so to answer this quick polling question. And one other note while you're answering the question, if you have any questions for us, we're going to have some time to answer questions towards the end of today's session. So I've got one question already in. We'll hit that in a moment. Feel free to add them at the bottom into the Q&A section below. And if we don't get to them today, we'll certainly respond back to you with an answer if we can't answer them live. So let's connect the dots here, right? What you've seen today is how HLA, oh, I apologize. Everybody said yes. That's fantastic. 100%. What you've seen today is how HLA and LEAP can create a gateway for broader IT operations management maturity. The outcomes are powerful. Agencies can build stronger resilience, reduce risk with smarter prioritization, and they can deliver on missions more effectively, okay? So it isn't just about solving today's problems. It's about laying the groundwork for tomorrow. And ServiceNow is here as a long-term partner to you, helping federal agencies modernize at your own pace while preparing for future AI adoption. So we have one last poll, and it's a quick one as well. Do you see this tool as a good starting point to automate out repetitive tasks? All right, again, 100%. That's fantastic. I love to see that. So let's go into our Q&A section. And Mark, I'm going to start this one off, and I will probably need a little bit of your assistance as well on this one. I'm going to paraphrase this one because it goes into an agency. But basically, in short, it's about an on-premise versus an in the cloud or cloud first strategy. And is there a difference? How can one versus the other be utilized? What I would say to start with is that HLA can be used on-premise or in the cloud. So it doesn't matter to ServiceNow which way you choose to go. Now, Mark, is there a benefit to having one in the cloud versus one on-premise from a U.S. federal perspective?
Now, yeah, of course. So it all depends on your particular agency's restrictions, right? So there may be times where it's required to have HLA on-premise because of the sensitivity of the actual servers that are sending the data, and they can't leave a certain location, physical location, in which case we'd obviously want to implement AI ops on premise. With implementing AI ops through the cloud, of course, you get more leeway in terms of the sources that are available to you, right? With the hyperscaler connections that we have, etc. So again, we aim to be as flexible as possible. We also aim to be as scalable as possible as well. With being in the cloud in our data center, obviously we would handle the infrastructure, and therefore we'd be able to scale up fairly easily and automatically wherever possible. And again, on premise, that would be more on the agency's responsibility, obviously, to scale out infrastructure as you utilize this solution more and more. So that would be a key thing to consider. But again, if there is no option of sending data outside of a particular location, you have to go on premise, in which case, we'll go with the on premise option.
Fantastic. I'll pause for a moment. Are there any other questions from the audience? It doesn't look like we have any others, so we will probably be leaving early. All right, with none other coming in, on behalf of Mark and myself, I'd like to thank you for joining today. We look forward to continuing the conversation and supporting your mission. Again, I'm Chris Russick, Mark Brzezinski. If we can be of further assistance, please don't hesitate to reach out. We're here to help you. Thank you very much.
Thank you.